Hello, this is a demonstration of how to calculate a z-score from a raw score. So you'll see that I have over here on the right written out the the raw scores on the scale and the z-scores that correspond on the scale. So I put 100 in the middle for the raw scores, and I added 15 to get 130, and added 115 and added 15 again to get 130. Then I started at the 100, which is the mean, and I subtracted 15 to get 85 and subtracted again to get 70. And these correspond with the z-score 0, 1, 2, -1, and -2. And this represents the data for this IQ test that has a mean of 100 and a standard deviation of 15. So as you can see on the bottom, if we had someone who got an IQ score that was a nice round number, such as 115, as I have marked here in red, this would be super easy. We wouldn't need to do any calculations. We would know that in that example, if x equals 115, then z equals 1. And we can see that because they are aligned on our chart. But unfortunately, most of the time, we don't get those kinds of nice round numbers. And in this example, Sonia received a score of 122. And so we're going to need to do some calculations. But the first thing we'll do is let's put this 122 about where it would be on the distribution so we can get an idea of what we're looking for. So if we put that, it would be somewhere between 115 and 130. I'm going to put it right here. Say it's going to be approximately there. And I'm going to call this x equals 122. It would actually be a little closer to the 130, but that's okay. We know that the z-score is going to be somewhere between 1 and 2 because that's where the score of 122 falls. So what is the formula? Well, it's quite simple. In this case, z equals the deviation x minus m divided by the standard deviation. And if we continue that, we would see that z equals, substituting in, x 122 minus m 100 divided by the standard deviation, which is 15, which is equal to 22 divided by 15. And if I put that into my calculator, I find that that score equals 1.46667, which is probably 1.466 repeating. And I always want to round it to the 2 decimal places. So we'll give this a z-score of, let's make a fatter marker here, of 1.47. And so we can see that this makes sense. It's between 1 and 2, and we've got the raw score marked. Now we have the z-score marked, and that's how we work that calculation. Let's do another example below. Here we have a new chart set up, and we say the average life expectancy, for people in a particular retirement community is 80 years with a standard deviation of 6. I'm going to underline these so that they seem very obvious to me when I go back for information. Martha is still living at 100 years. What is her z-score? So the first thing I'm going to do is plot out my raw scores and my z-scores on the graph. I'll put the mean in the middle, 80. And let me get a skinnier marker here. And I would add 6, the standard deviation, to get 86. And another 6 to get 92. I'll subtract 6 to get 74 and subtract 6 again to get 68. So those are our raw scores or X scale. And in blue, let's just put the numbers for the Z scale. The Z scale always has 0 in the middle, 1 and 2, and -1 and -2. And if we had someone who was still living at 92, we know their z-score would be 2. But we don't have that. We have Martha still living at 100 years. What is her z-score? So we can see here that our scale isn't even quite big enough. But you'll recall that this distribution, in theory, goes on to infinity. So let's put in some more standard deviation marks, approximately the same distance apart, even though we can't even see how small the proportions are that go that far. And we will put 92 plus the standard deviation 6 equals 98, plus the standard deviation 6 equals 104. And Martha's score of 100 years is going to fall in the middle here somewhere. So let's put a flag for her and let's mark her at 100. And what does this correspond to? Well, we know that 98 corresponds to 3 standard deviations. 104 corresponds to 4 standard deviations. So we know the score is going to be somewhere between 3 and 4. Let's calculate and find out what it is. Our formula, z equals x minus m divided by standard deviation equals Martha's age of 100 minus the mean of 80 divided by the standard deviation 6 equals 20 divided by 6. And if we plug that into the calculator, we get 3.33333, which we will round down to 2 decimal places for a final result of, let's get the fat marker out, z equals 3.33. Does this seem right? Well, we said that our answer would be somewhere between 3 and 4. This answer is between 3 and 4, so we'll conclude that this is correct.